Hi, it's me again, Daniel Fernandez Davila, and we're going to review quickly three important features of the geography of South America. One will be tectonism and formation of the mountains. The second one would be latitude and the formation of the Amazonian basin. And the third one will be two important currents that I wanted to mention you as an introduction: the Humboldt current and the Australian current that approaches to South America, and how they affect the weather in the continent. Let's start quickly with the tectonism. If you have a close view of the continent, what you can see is this narrow, deep blue strip that runs in front of the continent in the western side of South America. This is actually what we call a subduction zone. Is the zone of encounter, or the encounter zone of the Nazca Plate and the South American continent. The trench continues in front of Central America, and you lose the vision of that trench because it actually goes inside, and when it's California right now, it's called as the San Andreas Fault, and comes out into the ocean in Alaska, continues all the way to Kamchatka, Russia, and forms these deep trenches in the Pacific Ocean in front of the Philippines and Papua New Guinea. All the system of trenches in front of the continent, it's called the Rim of Fire of the Pacific Ocean. It's an active area of earthquakes and volcanoes. On the other side, you don't see any plate that is visible, and the only area where we have hundreds of volcanoes happen far away from the coast of Brazil is called the Atlantic dorsal, and goes along all this area. So what are the consequences of the proximity or the far distant position of these trenches from the continent in South America? First, because the trench forms really close of the western side of the continent, and the subduction zone is an area of constantly what we call orogenesis, or formation of mountains. You have the Andes. The Andes are not other thing but the product of the contact and clashing zone between the trench and the continent. You can have high mountains and corrugated terrain due to the fact of the clashing area between the plate of Nazca and the continent. This is actually the Andes. It was formed 80 million years ago. Very recent formation in terms of geology for the Andes, and it runs in the western side, very close to the Pacific Trench. On the other side, you don't see major mountains, again because we have an absence of subduction areas. Yes, definitely you have the Brazilian highlands that are actually located in this area. They are not as tall as the Andes, but the explanation is that they are not as tall as the Andes because they were formed probably millions of years before the Andes. So they have been passing through a process of erosion, and they are like right now tall, smaller than the Andes. The Andes are basically brand new in terms of geology and still in a process of formation, whereas the Brazilian highlands are pretty old mountains. It's exactly the same with the Appalachian Mountains. The Appalachian Mountains are not as tall as the Andes, but they are extremely old, probably from 300 million years ago, and has been through a process of erosion. That's what they are like right now, not as tall as the Andes. But that's tectonism here. Now, tectonism not only create mountains, but what they generate is actually a continental division of waters. So if we activate the Andes here, you have two huge basins, as we mentioned before, the Amazonian basin and the Western Basin, which is located on the western side of the continent. All the rivers, absolutely all the rivers that come from the Andes to the Amazonian Basin, or to the Rio de la Plata Basin, or to the Orinoco Magdalena, have to travel more than 2,500 miles from 21,000 feet to zero. So because this is a long distance, what you're going to have is narrowing rivers, like windy rivers, that actually do this kind of a serpent or snaky pattern there. On the other side, in the western side, you have not like windy rivers. On the contrary, you have straight, very powerful rivers, more than 100, that ran from the Andes down with tremendous force, and in between you have pockets of deserts. So basically you have two huge basins. The Amazonian Basin and the Pacific Basin. Come on, man. Shh. There it goes. What else we have here? If you go close, I just want to show you quickly the two differences between this type of rivers. There it goes. Let's go to one so you can see what I'm talking about when I mention windy, so you can basically envision one of these rivers. Let's see. This is one type of river in the... Look at this. This is a classic river from the Amazonian Basin. It's because the long distance it has to cover between the mountains and the mouth of the river that the rivers became windy. These sea sections here are abandoned elbows, we call it elbows, abandoned elbows of the river, because every year the rivers turn their curves and abandon these, forming small lakes. On the other side, let me show you what I was talking to you about these rivers. Let's see one of the rivers in the west. Now look at this carefully. This is the delta of the river. Narrow, and look at how narrow it goes here in the middle of the mountains. And here is the valley. The river runs inside of the mountains. There is no room to form a windy pattern, and on the contrary, what it does, it's a straight, long, narrow pattern that is very actually destructive and cause a lot of erosion in this section. So remember that you have two big basins, the Amazonian Basin and the Western Basin here, formed by the Andes. You have also independent small basins such as Rio de la Plata and the Orinoco Magdalena basins on the upper section here. And those all form because the Andes are rising due to the force of the collision of the Nazca plate here in the continent. The second thing that I want to mention you quickly is the formation of the Amazonian Basin here. This is due to the heating pattern that happens along the equatorial line. In order to do that, I'm going to activate the equator here in the grid. You can see the tropics. So this is the area where the sun strikes mostly 90 degrees. The equator is 90 degrees every day of the year. If you pass the tropics, the impact of the sun will be much more tangential. If you are in between the tropics, the force of the sun is really almost if not perpendicular to planet Earth. But if we activate the clouds, that's what I want to activate, you can see concentration of clouds in all this area in the equator. That is showing you the amount of evaporation that you have from that area, and it causes tremendous quantity of rains and precipitation. If you go close to the tropics, as it happened in the north, in the south, you don't see too much that heat and that concentration of precipitations, producing strip narrows of deserts such as Atacama Desert in this area. So this is all the Amazonian jungle. Look at the connection between the equator and the clouds formation in that area. And the third and last pattern that I want to mention to you, it's two important currents as an introduction. These two currents are very famous and run in the western side of the continent. One of the currents is called Humboldt Current and comes collecting cold waters, runs parallel to the coast of South America and turns almost in the border between Ecuador and Peru to the left. Then continues all the way here in counterclockwise pattern, and it's constantly doing this movement. The other current that comes from Australia, it's a warm current. It's not cold, but it's warm. It's very warm current, and comes again, and does this pattern. Comes here, and then intersects this one, and comes all the way here, and does this one. So you can imagine what happened here. You have an area of contact of two currents, one warm, that is the yellow, and one red, that comes bringing cold waters from the Antarctica. The intersection of these two currents in front of the coast of South America can happen in one small area or can happen in a widespread area, that can go from Honduras, Guatemala, all the way to the coast of Chile. Now, if the warm water touches and intersects the cold water, what you produce is vast amount of interchange of heat and cold areas, which produces actually transpiration, evaporation, humongous quantity of evaporation in these sections of the ocean. If the contact area between the two currents happen close to the coast, then all this evaporation will travel to the east and will clash against the mountains, which is a huge wall, and then it will torrentially rain on the coast of Peru, Ecuador, and Bolivia, and in Chile, producing what we call as the El Niño phenomenon. If the areas are extended and the intersection happen much more in Ecuador, Panama, and the current of Humboldt goes a little bit further north, then the extension of the torrential rains will be actually greater. So it is the intersection between these two currents, one cold and one warm, that produces El Niño effect, which is so important to understand for the people in South America. You can find El Niño also in scientific books as ENSO, Event Niño Southern Oscillation, is the scientific term for the encounter of these two currents. If the two currents have their encounter point far away from the Andes, the torrential rains will be dropped in the Pacific Ocean, and that will be a year with no Niño. It's called El Niño because these encounters happen mostly in the year of December, which is the Christmas time, and they are referring to Jesus Christ as El Niño. So these two currents, the Pacific Trench and the circulation of winds and clouds that are determined by the equator and the tropics, actually all of these factors are extremely important to understand patterns of formation of ecosystems, areas of rain, and the diversity of fauna and flora in the continent.